Hello friends, welcome back. Let's continue with the derivative of trigonometric functions. Let's try to find out the derivative of sine to the power of nx in this session and also see some more examples related to that. So how to find out the derivative of sine to the power of nx? If you remember, we have used chain rule and we can use the chain rule to find out the derivative of sine to the power of nx, because sine to the power of nx is nothing but equal to sin x whole to the power of n, and which is in the form of x to the power of n. So how we can solve this problem? We will say we can directly use the chain rule. Start from out, we have to go to inner. So at the higher level I see this is nothing but u to the power of n, where u equal to sin x. So my first statement to give the derivative, what I will write is, I will say I see something to the power of n, that is x to the power of n, and we know derivative of x to the power of n is n into x to the power of n minus 1. So I will say n into x. My x is now sin x, so I will say sin x whole to the power of n minus 1 multiplied with, now I see that sin x itself needs to be differentiated again, because I have to find out the derivative of that. So I have to start from outer to inner according to the chain rule. So sin x derivative I have to write. So that is d by dx of sin x. That's equal to nothing but n into derivative of sin x is cos x, we know that, and that I have to multiply it with sine to the power of n minus 1 x. That's a derivative of sine to the power of nx. If you are not comfortable with that, you want to do it in elaborate, we can do like that also. We can say y equal to sin x whole to the power of n, that's equal to u power n. Then what we need to find out is dy by dx. We will say that is nothing but equal to dy by du multiplied with du by dx. Now what is u? U equal to sin x. What is du by dx? Du by dx is equal to cos x. What is dy by du? Dy by du equal to n into u to the power of n minus 1. So now can I say dy by dx equal to dy by du, that is cos x, multiplied with, actually du by dx is cos x, dy by du is n into u to the power of n minus 1, which is equal to n into cos x into u is sin x to the power of n minus 1, that is sine to the power of n minus 1x. This is nothing but equal to what we have done in one step. So if you are not comfortable in doing it in one step, you can take them as u, then you can find out du by dx, and then you can find out dy by du. So the chain rule says that if you want to find out dy by dx, that's nothing but equal to dy by du into du by dx. If you have again u in terms of w, then it will become dy by du into du by dw into dw by dx, but at the end you will be getting dy by dx. Now once we have found out the derivative of sine to the power of nx, let us see how to find out the derivative of x by sine to the power of nx. Let's have a look at that. Just now we found the derivative of sine to the power of nx. So let's leverage that to find out the derivative of x by sine to the power of nx. Now you can see the function for which we need derivative is in the form of u by v, and we can apply the quotient rule. The quotient rule says derivative of y or y dash equal to v into u dash minus u into v dash divided by v square. We know u equal to x, and we know v equal to sine to the power of nx. What is u dash? U dash is equal to 1. What is v dash? V dash just now we found, that is equal to n into cos x into sine to the power of n minus 1 into x. We know that. So let's go ahead straight forward and substitute in the formula. Derivative of x by sine to the power of nx equal to v square. V square is sine to the power of nx, sine nx whole square. Can I say it as, let us write it down as sine to the power of, can I say sine x whole to the power of 2n? Because sine nx whole square equal to sine x whole to the power of 2n. A to the power of b to the power of c equal to a to the power of bc. We can do that. No problem with that. Okay. Now what we have here, v is sine to the power of nx, sine to the power of nx into u dash, that is 1, minus u is x into v dash. V dash is n cos x into sine n minus 1 x. Now my next step will be to write sine to the power of, can I write it as sine to the power of 2nx? I can take sine to n minus 1x common. If I take that common, I will have 1 sin x here. If you are able to understand that, because sine to the power of n minus 1x into sine to the power of 1x, n minus 1 plus 1 is n. I hope you are okay with that. Minus x into n cos x, because sine n minus 1x we have taken already common. This is nothing but equal to sin x minus nx cos x divided by, now let us see here, I have, this is nothing but sin x whole to the power of n minus 1 divided by sin x whole to the power of 2n. So how this will become? This is nothing but sine. I will have 2n. If I bring n minus 1 to the denominator, it will become minus n plus 1. That is sine to the power of n plus 1 x. Not to confuse you, let me just erase this part. But what we have done here is sine to the power of n minus 1x by sine to the power of n minus 1x divided by sine to the power of 2nx equal to 1 by sine to the power of n plus 1 x. Just to understand that. So that's your answer. Sin x minus nx cos x divided by sine to the power of n plus 1 x. In the next session, we will look into some more examples related to trigonometric functions, and try to focus more on chain rule related problems, like how to find out the derivative of log of secant x plus tan x, or how to find out the derivative of tan of root secant x or secant of root tan x. How to find out those derivatives. That type of problems we will look in the next session. Thanks for your time. I'll catch you again. Bye for now.